Assalamualaikum warahmatullahi wabarakatuh. Hello guys, we are from group 2. The member is Kafania Lutfa, Miftaqul Orsya, and Salsabila Rohma. Today, we would like to explain about formulation of hypothesis, alternative of hypothesis, null hypothesis, statistical hypothesis, and evaluating in hypothesis. Formulation of hypothesis. Hypothesis in quantitative research method needs to be structured before the data gathering and interpretation phase of research. A well-grounded hypothesis indicates that the researcher has sufficient knowledge in the area to undertake the investigation. The hypothesis gives directions to the collection and interpretation of data. The example of a simple association between two variables, y and x. First, the first hypothesis provides a simple statement of association between y and x. Nothing is indicated about the association that would allow the researcher to determine which variable, y or x, would tend to cause the other variable to change in value. The second hypothesis is also a simple statement association between y and x, but this time it may be inferred that values of y are in some way contingent upon the condition of the x variable. The third hypothesis is the most specific of the three. Not only does it say that y and x are related and that y is dependent on x for its value, but it also reveals something more about the nature of the association between the two variables.
Null hypothesis. The null hypothesis states that there is no relationship between two population parameters that are an independent variable and a dependent variable. If the hypothesis shows a relationship between the two parameters, the outcome could be due to an experimental or sampling error. However, if the null hypothesis returns false, there is a relationship in the measured phenomenon. The null hypothesis is useful because it can be tested to conclude whether or not there is a relationship between two measured phenomena. It can inform the user whether the results obtained are due to change or manipulating a phenomenon. Testing a hypothesis sets the stage for rejecting or accepting a hypothesis within a certain confidence level. The null hypothesis is also known as the HO or no difference hypothesis. The example of null hypothesis. The example is plant growth rate is unaffected by the presence of cadmium in the soil. A researcher could test the hypothesis by measuring the growth rate of plants grown in a medium lacking cadmium, compared with the growth rate of plants grown in mediums containing different amounts of cadmium. Disproving the null hypothesis could set the groundwork for further research into the effects of different concentrations of the element in soil. Statistical hypothesis. A statistical hypothesis is a conjecture or statement about one or more populations in a study. Statistical hypothesis is one way of testing an analysis by using some data from the overall data in quantitative research. A statistical hypothesis is an operational statement in quantitative research that is translated in the form of statistical numbers according to the measurement tool decided by the researcher. Statistical hypotheses can be two things, namely temporary explanations or predictions about things to be studied. The statistical hypothesis should relate to the overall aspect of the data used.
The next is evaluating hypothesis. When you are evaluating hypothesis, you need to account for both the variability in your sample and how large your sample is. Based on this information, you like to make an assessment of whether any difference you see are meaningful or if they are likely just due to chance. This is formally done through a process called hypothesis testing. There are 5 steps in hypothesis testing. The first is specify the null hypothesis. The second is specify the alternative hypothesis. The third is set the significance level A. The fourth is calculate the test statistic and corresponding p-value. And the last, drawing a conclusion. Step number 1. Specify the null hypothesis. In research studies, a researcher is usually interested in disproving the null hypothesis. The null hypothesis is a statement of no effect relationship or difference between two or more groups or factors. Example: there is no difference in intubation rates across age 0 to 5 years. The intervention and control groups have the same survival rate. Or the intervention does not improve survival rate. There is no association between injury type and whether or not the patient received an intervention in the pre-hospital setting. Step number 2. Specify the alternative hypothesis. Alternative hypothesis is the statement that there is an effect or difference. This is usually the hypothesis the researcher is interested in proving. The alternative hypothesis can be one-sided or two-sided. We often use two-sided tests even when our true hypothesis is one-sided because it requires more evidence against the null hypothesis to accept the alternative hypothesis. Step 3. Set the significance level A. The significance level is generally set at 0 or 5, denoted by the Greek letter alpha. This means that there is a 5% chance that you will accept your alternative hypothesis when your null hypothesis is actually true. The smaller the significance level, the greater the burden of proof needed to reject the null hypothesis, or in other words, to support the alternative hypothesis. Step 4. Calculate the test statistic and corresponding p-value. Hypothesis testing generally use a test statistic that compare groups or examines association between variables. When describing a single sample without establishing relationship between variables, a confidence interval is commonly used. The p-value describes the probability of obtaining a sample statistic as or more extreme by chance alone if your null hypothesis is true. The p-value is determined based on the result of your test statistic. So, your conclusion about the hypothesis are based on your p-value and your significance level. The last step is drawing a conclusion. The conclusions also translate into a statement about your alternative hypothesis. When presenting the result of a hypothesis test, include the descriptive statistic in your conclusions as well. Report exact p-values rather than a certain range. So, the conclusion of evaluating hypothesis: reject the null hypothesis in favor of the alternative hypothesis. The difference in survival between the intervention and control group was statistically significant. There was a 20% increase in survival for the intervention group compared to control, and failed to reject the null hypothesis. The difference in survival between the intervention and control group was not statistically significant. There was no significant increase in survival for the intervention group compared to control.